So today we are going to discuss some questions related to laws of motion, whatever we have discussed up to this point. So a light string passing over a smooth light pulley connects two blocks of masses m1 and m2. If acceleration of the system is g upon root 2, then ratio of masses m1 and m2 is. So you are going to have a pulley here. So there is a pulley like this, and a string is passing over it. Suppose on this side you are having mass m1, this is mass m1, and this is mass m2, and this is mass m2 and m1. Now, because mass m2 is greater than m1, so we can assume that it is moving system, this mass m2, it is moving in the downward direction with an acceleration a. And this acceleration is how much? That is g upon root 2. ठीक है ना, the acceleration of the system is g upon root 2 and we have to find out the ratio of masses. Now, if you look at this, then weight of this mass m2, that is going to act in the downward direction. m2g, that will act in the downward direction. And this is a string, so a tension force will act on this block m2 in the upward direction. This is tension T. So what will be the equation of motion? In which direction we are saying acceleration is there? Acceleration is in the downward direction. So which force will be greater? m2g will be greater. So m2g is the force that is leading to the motion in the downward direction. Opposing force is tension in the upward direction, so minus T. And this will lead to an acceleration of mass m2. So that will be equal to m2a. This will be. This will be the equation of motion for this block m2. Now, if this block is moving in the downward direction, so automatically this m1 block, it will move in the upward direction with the same acceleration. Weight of m1 will act in the downward direction, m1g, and tension will be in the upward direction. Because motion is in the upward direction, so tension is the leading force. Tension will take it up. So this will be T minus opposing force is weight of block m1. So this will be minus m1g. And this will lead to, this net force will lead to the motion of this mass m1 in the upward direction with an acceleration a. Acceleration a. So now add both these equations. So on adding, on adding these two equations, this tension is going to cancel out. And this will be m2 minus m1 into g. And this will be equal to m1 plus m2 into a. Now, what they are providing us, they are saying that the acceleration of the system is g upon root 2. So substitute g upon root 2 here. So I will write m1 plus m2, and this will be g upon root 2. And this will be m1, m2 minus m1 into g. So g will cancel out. And this will be root 2 of m2 minus root 2 of m1, and that will be equal to m1 plus m2, m1 plus m2. So here, if I bring this m1 on this side, then this will be minus root 2 is here, and minus 1, so minus 1, so this will be root 2 plus 1, okay? Root 2 plus 1 into m1 will be here. And on this side, this will be m2. And if you bring this on that side, then this will be minus. So I take minus common. So this will be root 2. And this will be minus 1. It will be like this. This minus will cancel out. And m2 will be common here. So this minus will cancel out. And this m1 upon m2. That will be how much? That will be root 2 minus 1 divided by root 2 plus 1. So option A will be the correct answer. So this type of question they can ask in 1 or 2 marks. Okay, so this is question number 1 beta. This is question number 1. Please note it down. Please note this one down. Now go to the next question. Question number 2 here. Question number 2. Just 1 second. Question number 2 here. A person of mass 60 kg is made a lift of mass 940 kilogram, is inside a lift of mass 940 kilogram and presses the button on control panel. The lift starts moving in the upward direction with an acceleration 1 meter per second. If G is equal to 10 meter per second square, the tension in the supporting cable is. So what they are saying like this is a lift here. Okay? Lift is here. In this lift, there is a person. Okay, na? A person is standing here. This is a person here. And this lift is attached with the cable. Okay, this lift is attached with the cable. So weight of this person and this lift together, okay, na, that is acting in the downward direction. So this will be 60 plus 540 G. This is the weight of the person as well as of lift. So together their weight is acting in the downward direction. Suppose tension in this string that is attached with the lift, ठीक है ना, that is, so this is supporting cable. In supporting cable I am assuming tension is T and this lift is moving in the upward direction with an acceleration A equal to 1 meter per second square.
सर वहां पर 60 प्लस 940 होगा ना?
This will be 940 बेटा, ठीक है, correct, this will be 940. So this will be how much? This will be 1000 G. This will be 1000 G. This will be. So try to understand, motion is taking place in the upward direction. So who is the leading force? Tension is the leading force and this is opposing force. So I can write here T minus this 1000 G. G you can choose as 10 meter per second square and this will be mass. So mass is mass of the lift plus this person is 1000 into A and A is equal to 1. ठीक है ना, A is equal to 1. So this T will be how much? This is 1000 into 10. This will be 10,000 on this side plus this 1000. So tension T will be, this will be this one. ठीक है ना, 11,000 Newton. This will be 11,000 Newton. So this will be the answer of this question. What will be the answer of this question? That will be option C. Option C is the correct. Yes, beta, please.
Right hand side 1000 into 1
One is the acceleration, beta. I have written like this. This is T, tension in the upward direction, minus weight of this person,
into mass.
M,
Sorry. Yes.
M plus M into G. Weight is acting downward. ठीक है ना, this net force, due to this net force, this system is moving in the upward direction with an acceleration A. So I will write M plus M into A. And A is given as 1 meter per second. This M plus M is 1000. So here this is 10, this is 1. So by solving it, you will get it 11,000 Newton. So tension is 11,000 Newton, option C. Option C is the correct answer, beta. Option C is the correct answer. Is it okay?
Yes.
Next question, beta. Question number 3. Next question, beta. Question number 3. At any instant, the velocity of a particle of mass 500 gram. So how much mass is there of the object? That is 5000 gram. Sorry, this is 500 gram. 500 gram. Or you can say this is 1 by 2 kg. ठीक है, I have divided it by 1000, so 1000 kg will be the mass. And what is the velocity given? Velocity is this. The velocity is 2t, and this will be I cap plus 3t square. 3t square and this will be J cap. It will be J cap. This is velocity V. Okay? Meter per second. What is the unit here? They have given unit as meter per second. If the force acting on the particle at time t equal to 1, so at t equal to 1, I'm writing here, at time t equal to 1, force that is acting on it, that is I cap plus x j cap, and it is in Newton. Unit is Newton. Then value of x will be. So here velocity is given. So if I differentiate this with respect to time, I can find out acceleration. So dv by dt, that will be equal to acceleration. And acceleration is how much? Acceleration will be, this will be 2 I cap plus, on differentiating it, this will be 60 and j cap. J cap. This is the acceleration. If you know the acceleration, you can find out the force acting on this object, on this particle. What will be the force that is acting? Force will be equal to mass into acceleration. Mass into acceleration. Mass is 1 by 2. And acceleration is 2 I cap plus 60 j cap. J cap. So this will be I cap plus this will be 3t j cap. So this will be F. Now at time t equal to 1, if you at time at t equal to 1, t equal to 1, substitute t equal to 1, so what will be F? F will be equal to I cap plus 1 is here, so this will be 3j cap. If you compare these two expressions, whatever is given in the question and this one, I cap is okay, this is 3j cap, here this is xj cap. So what will be the value of x? That will be 3. So here value of x will be 3. ठीक है ना? This will be the answer. So option A is the correct answer. So option A is the correct answer. Now fourth question, that is a, now please go through this and then I will go move to next question. Then I will move to next question, please. So this was question number 3. Question number 4, beta. This is question number 4. This is a very simple question. Try to solve. ठीक है ना? Everyone, please try to solve. So two masses M1 and M2 masses are given, tied to a string, are hanging over a light frictionless pulley. What is the acceleration of masses when left free to move? Please solve it. ठीक है ना? Please solve it, beta. What will be the acceleration? If you remember, I find out because here mass M1 is greater, so it is going to move downward. So it should be equal to, I have already derived this in first part. So this will be M1 minus M2 divided by M1 plus M2 into G. This will be into G. So this will be 5 minus 4.8 divided by 5 plus 4.8. So because here this is 9.8, so value of G I am writing here 9.8. So this will cancel out by this and your answer will be 0.2 meter per second square. This will be the acceleration. So what will be the acceleration here? You have to remember this formula. You have to remember this one. So option
Sir?
C, yes, beta, please.
Sir, in which case we can use this formula? A is equal to M1.
When you are having this type of situation, suppose this is a pulley here, massless pulley. Okay, this is a massless pulley. Over this pulley, a string is there. Okay, na? A string is like this. On one side, you have attached a mass M1. On the other side, you have attached the mass M2. Okay, so tension will act in this direction and in this direction. Their weights are acting in the downward direction. This will be M1G. Weight of the second one is going to act in the downward direction, M2G. m2g. Now whichever is greater, ठीक है ना, either m1 is greater or m2 is greater. Suppose m2 is greater, suppose you are having m2 is greater than m1, then m1 will move down and m1 will up, move in the upward direction. What will be the acceleration in this in this case? So in this case, m2 is going to move down with this acceleration. It will be m2 minus m1 divided by m2 plus m1 and into g. But suppose reverse case is there. Suppose second case, if m1 is greater than m2. So in this case, this is going to move downward and this will move upward. So in this case, what will happen? Acceleration will be, because m1 is greater, m1 minus m2 divided by m1 plus m2 into g. Okay? This will be the first. So whichever is greater, that will be the first. Which one is lesser, lighter, that will be the second. And I have derived this formula here in the first one. Okay? Here I have derived this. So from here, look here. Take a look here at this equation. If you look at this equation, what will be A? A will be m2 minus m1 upon m2 plus m1 into g. Okay, so I have derived it. So here I was assuming m2 was greater. It was given in the question, so that's why this was. So please remember this formula. This will be very helpful. This will be a 1 mark or 2 mark question. Or they can modify it a little bit, but this is a simple but good question always. Next, this is a very conceptual and very good question. A ball of mass 0.2 kg. If you look at IT, if you look at your exam, ठीक है, then you will find out most of the questions from this section, Newtonian mechanics, they are very conceptual, very simple questions you are going to find out there. Just you should understand how to write the equation. Most of the time, equation of motion. If you can write equation of motion, you can represent the forces in right direction, then you can easily solve the question. So here, a ball of mass 0.2 kilogram is thrown vertically upward by applying a force by the hand. If the hand moves zero point 0.2 meter while applying the force, the ball goes up to 2 meter height further. Find the magnitude of the force. G equal to 10 meter per second square. This is very interesting question, very good question. You can try. You can take a minute and solve. And it is not so simple also. It looks like very simple question, but it's not so. Please try. Please try. So what he is doing initially, ball is at rest. Your hand moves for how much distance? For 0.2 meter. Your hand moves 0.2 meter like this in the upward direction. Your hand move like this. It throw. And after throwing, this ball is moving up to a height of 2 meter. So it is going in the upward direction up to this height. Okay? Then you have to find out how much force is applied by the hand on the ball. Anyone tried? Hello? Anyone tried this question? So try to understand, initially ball was here, and suppose this is the hand of the person. Here, ठीक है ना, U is 0. U is 0. Now this hand takes this ball to this position. ठीक है ना? Takes this ball to this position. This is the hand. And in this case, how much distance is traveled by it? You can say this is 0.2 meter just. 0.2 meter here. ठीक है ना? This will be 0.2 meter. Try to understand here. Now its velocity, it will have some velocity v. ठीक है ना, it is going to have some velocity v, and with this velocity this ball is thrown, and with this velocity this ball goes up to a height of 2 meter. So this is 2 meter. 2 meter here, this v, it will be 0 at the highest point. ठीक है ना, you have to find out the force applied by the hand during this journey from here to here. What is the magnitude of the force? Now I have made it more simpler for you. Please try. Even after this, there is a thing that you have to understand. You are going to tell me, please. बताइए. So from here to here, try to understand. First, I want to find out this V. For this journey, for second journey, I'm saying this is second journey and this is first journey. So in second journey, second journey, ठीक है, second journey. When the hand has thrown, so automatically only acceleration that is acting, that is gravitational acceleration in the downward direction. So final velocity, so I am writing v square is 0. I'm using this equation, v square is equal to u square in the upward direction, so minus 2gh. I'm using this. So final velocity is 0, initial was v, so I'm writing it as v square minus 2 into g into h is 2 meter. So this v square is equal to 4 and 10. This will be 40. ठीक है ना, this will be 40. So what will be v here? V will be here root of 40. This will be. So v will be equal to root 40 meter per second. Is it okay up to this point? Hello?
Yes, sir.
Now consider this part. You have find out this is coming out to be root 40 now. This is root 40. So now consider this journey, first journey. In the first journey, this is a very good question, very conceptual question. I think this is given in H.C. Verma, if I'm not wrong. In I don't remember, but in first journey, and this was asked in the exam also. So this is v square this time. So this will be v square. I'm applying is equal to u square. And I don't know when hand is in contact. So I'm saying that during this journey, I'm saying acceleration is a. So I'm saying in the upward direction, acceleration is a. So I'm saying this is plus 2a and this is h1, I can say. So this initial velocity was 0. And this v square, this will be 40 final. V square will be 40 plus 2 and this acceleration a, and this is 0.2. So this is 0.4. So this a will be equal to 40 upon 0.4. So that will be 100 meter per second square. Is it okay up to this point? Hello?
Yes, sir.
Now,
Yes, sir.
now try to understand what is happening in journeys first. Try to understand when ball is in the hand and ball is in contact with the hand. So how this hand is applying a force on it in the form of contact force. So how this hand is applying the force on this ball, that is in the form of contact force that is acting in the upward direction. Weight of this ball, that is mg, that is acting in the downward direction, and net acceleration is a, whatever we have calculated. ठीक है ना, this will be, ठीक है, so this will be n, ठीक है, n will be equal to how much? N will be equal to, sorry, n minus, I can write equation of motion here. So n minus mg, that will be equal to ma. that will be equal to ma. So what will be n? N will be m g plus a. What is the mass? 0.2 kg. So right here 0.2 kg. This is 10 plus this will be 100. ठीक है ना? This will be 100. So it will be how much? This is equal to 0.2 into this will be 110. So 0 is gone. So this will be 22 Newton. So this will be the answer. ठीक है ना? This will be the answer of this question. This was a very tricky question, very good question, where you have to understand what is the meaning of contact force. When you are throwing the ball in the upward direction, actually that is the normal reaction that is applied by the hand. That is the force which hand is applying on this ball. So this was a very good conceptual question. Is it okay with everyone? Hello?
Yes, sir.
Yes, sir.
Good. Next question, beta. This was a question. Okay. This is a very simple question. So please find out. This type of question, more or less, this type question was asked earlier in your exam. So try to understand a body of weight 2 kilogram. So this is 2 kilogram weight. Okay, it's suspended as shown in the figure. The tension in the horizontal string is. So try to understand here. In this direction, I am assuming this tension is T2. T2. This is T1. And here, ठीक है ना? Here, whatever tension you can say, whatever tension is there, that will be equal to 2 kilogram weight or 2 mg. So I'm saying in this direction, how much is acting? That will be 2g. ठीक है? G is gravitational acceleration. So this is 2g. 2g is acting here. If you want to draw, ठीक है ना? If you want to draw the tension here, suppose T3 here in this way, then this T3 will be 2g. And here at this point, in that case, you have to apply T3. So you can consider like this if you want. So resolve this. So if this is 30 degree, then if I extend this angle, this will be 30 degree. ठीक है ना? This will be 30 degree. So this will be T2 cos 30 degree. And this, if you resolve it in the upward direction, that will be T2 sin 30. Sin 30. So what you do here, this T2 cos 30 degree, this is going to balance this T1 force. T1 force. And this T2 sin 30, T2 sin 30 degree, this will be balanced by this T3, and T3 is equal to 2g. So I'm writing here 2g. Okay, divide these two equations. So T2 will cancel out by T2, and this will be tan 30 degree. And tan 30 degree, it will be 2g upon T1. Now tan 30, 1 upon root 3. And this will be 2 into 10, this will be 20 divided by T1. So what will be T1? T1 is, or even you can write G because they are saying in kilogram weight. So it's better for me to write it as just 2G. So I'm writing it at 2G only. So this will be 2 root 3 into G. So much Newton, this is in terms of Newton, and I can write it as 2 root 3 kilogram weight. ठीक है? I can also write like this. So my answer is 2 root 3. So here option C is the correct answer. So here option C is the correct answer. So this is question number 6. This is question number 6. Is it clear? Can I go to next?
Yes, sir.
Good. Next is this question number 7. The upper half of an inclined plane with inclination phi is perfectly smooth, while the lower half is rough. Okay, while the lower half is rough. So basically inclined plane, it is divided into two parts. So here it is like this. Consider an inclined plane. So from here to here, this is smooth. No friction is acting here. Okay, in this part there is no friction that is acting. And for the lower part is rough, so friction will be there. A body starting from rest at the top will again come to rest at the bottom if the coefficient of friction for the lower half is given by. So you have to find out the friction force that is acting here. In this part, coefficient of friction you have to find out here in this case, here. So that this body which is starting from rest here, it is accelerated in this part. And then automatically due to friction, it is deaccelerated from here to here. So body will be at rest at this position. So they are equal halves. So try to understand here they are equal halves. This is deaccelerating zone and this upper one is accelerating zone. And these distances are also equal. If I say this is S, then this lower part is also S. Remember this. And angle of inclination, plane of inclination, that is phi. Okay? So what will be the acceleration in this part when this block is here? When the block is here, no friction is there. Mg is acting in the downward direction. If you resolve this here, this angle will be alpha and this will be mg cos alpha. Cos alpha. And this mg cos alpha, this will be balanced by the normal and there will be one unbalanced force. Unbalanced force will be here mg sin alpha. This will be mg sin alpha. So what will be the acceleration during this part? Okay, only one force is acting here. So for the first, I write it as A, this is B and C. Okay, from A to B. From A to B. Force that is responsible for the sliding of this block is equal to mg sin alpha. Mg sin alpha. No friction force is there. So if I bring this here, this will be F by M and that will be acceleration along this inclined surface. This will be G sin alpha. How much it will be? This will be G sin alpha beta. So this will be the acceleration here. Okay, na? This will be the acceleration here. Now second part of the journey from here. Okay, now come to the second part of the journey from B to C. From B to C. What will be the deceleration here? So if I draw the block here, then its weight is still acting in the downward direction mg. This component of weight, this is phi, so this will remain same, mg cos alpha. In this direction, force is how much force is acting? This force will be mg sin alpha. Sin alpha. Normal reaction will be there. This will be normal reaction. But this is a rough inclined plane here. This part is rough. So automatically a friction force kinetic, because block is moving, so kinetic friction force is going to act. So what is the net force that is acting on this block? If this is moving in the downward direction, try to understand. Okay, if it is moving in the downward direction, then I'm writing it as A1. So net force which is responsible for its slide in the downward direction, that will be mg sin alpha. Mg sin alpha. Try to understand. This is the opposing force here minus Fk. What will be Fk? Can anyone tell me? What is the expression for Fk? What will be Fk? That will be equal to mu k, and this will be equal to n. So this will be mu k. What is n? N is mg cos alpha. So what is n here? N is mg cos alpha. Cos alpha. So right here mu k mg cos alpha.
सर
Yes, beta.
आपने वो mg उसको तोड़ा लाइक mg cos alpha and mg sin alpha में, तो वहाँ आपने phi क्यों लिखा है? अब
This should be phi, na? Not alpha. This should be phi. This angle is phi, beta. ठीक है?
ओके, और एक क्वेश्चन सर, फर्स्ट हाफ वाले पार्ट में वो phi क्यों नहीं हुआ, वो अल्फा क्यों है?
I have wrongly written it as alpha. ठीक है? Otherwise it is phi. Throughout it is phi. This is given as phi. So I have wrongly written. I am making it correct, beta. So throughout angle is same. So I'm writing it as phi, converting it into phi. So this is also phi. Please make it correct. Sin phi. This will be. So from B to C, mg sin phi, it is acting downward. This is minus Fk and Fk. So it will be mg sin phi minus this will be mu k mg cos phi. This will be mg cos phi. ठीक है? This will be F. If I bring this here, so what will the acceleration due to this force? I can write it as F2. F2. So this F2 divided by m, this will be A2. ठीक है ना? This will be equal to A2. So A2 will be how much? This will be equal to divide this by m. So this will be G sin alpha. G sin alpha minus mu k and this will be G cos alpha. G cos alpha. ठीक है? This will be. Now try to understand, this will be a dx. You are aware that this will be a deaccelerating one. This will be deaccelerating one. So if I should write, so I should introduce minus sign here. Try to understand from here to here. ठीक है ना? From here to here, this will be. So this will be accelerating zone, and from B to C, this will be a deaccelerating zone. This will be a deaccelerating zone. If deaccelerating zone is there, then this will be a greater one. So I can write minus, this will be minus mu k. I write like this, mu k, this will be G cos alpha. This will be greater as compared to this minus G sin alpha. So this is deacceleration here. So A2 is actually deacceleration, and this is acceleration. So this part is for accelerated motion, this is for deacceleration. Now what he is saying, from here to here, it is accelerating. ठीक है? So automatically from here to here, in traveling this distance as, it will accelerate and it will acquire some velocity. From 0 to v it will become, and from here v to 0 it will become. ठीक है ना? So if you look at this equation, so for the first part, it will be like this. Try to understand, for the first part, it is going to achieve a velocity v square from A to B. It will acquire velocity v square. Starting velocity was 0 plus 2a1, and you can say this is s. How much distance is traveled? That is s. In the second part, it will from B to C. What will be? Initial velocity is v square, final velocity is 0, and it will be plus 2a2s. It will be like this. So what will be v square here? V square here will be minus 2a2s. Now equation 1 and equation 2, they are equal. So v square will be equal. So these two will be equal to a1 s. This will be equal to minus 2 a2s. So this s will cancel out, 2 will cancel out, and this a1 will be equal to minus a2. And we are aware about it because for half of the journey it will be accelerated, it will achieve some maximum velocity, and from that maximum velocity it will start deaccelerating and it will become zero. So whatever is the acceleration in the first half, that will be equal to deacceleration in the second half. This is. Now substitute these expressions here. What is the expression of a1? G sine phi. This will be G sine phi. Here I write G sine phi. And minus, when you will substitute a2, minus, it will cancel out. This minus and that minus will cancel out. This will be mu k g cos alpha, mu k g, mu k g cos alpha, sorry, cos phi. So don't confuse with this theta and phi, that only one angle is there. And minus, this will be g sine phi, g sine phi. Bring this g sine phi on this side. So this will be 2g sine phi and that will be mu k g cos phi. G will cancel out and mu k, it comes out to be 2 times tan phi. This is a very good question. First, it is giving us a understanding how to find out acceleration in these two cases. And second, okay, basically this concept that for the first half it is accelerated and then for the second half it is deaccelerated. Then we should understand this aspect directly. So you are going to start from here. If this type of question is there, then you should understand distances are same. So automatically, whatever is the acceleration, that is going to counterbalance this this will be counterbalanced by the deceleration. So initial velocity is 0 and final will become 0 only if this condition is satisfied. So answer will be 210 phi. So what will be the answer here? Answer will be 210 phi. Is it okay?
Yes, sir.
Good, Peter. So this was another question.
Sir,
Yes, Peter.
so in this case, we can start from A1 is equal to minus A2,
A2.
right?
Yes, if we understand. If we
Yes,
understand
sir.
the concept, then automatically we are going to start from here and it will be a very small, very simple question. Next.
Okay.
A body of mass 2 kg. Actually, here up to this point, I have not discussed one more type of question where pseudo forces are involved. So in the next class tomorrow, I will discuss first pseudo forces and I will include the questions of pseudo forces with Newton's laws of motion or equation of motion questions and in these sliders and all these things. Okay? So that concept is left. So in the first class tomorrow, I will discuss pseudo forces and related question, and then I will start discussing work, energy, and power. So question 8, next question, beta. A body of mass 2 kg is placed on a horizontal surface having kinetic friction 0.4. So kinetic friction is mu k is 0.4. Okay. And second, this mu s is 0.5. That is 0.5. If the force applied on the body is 2.5 Newton, then frictional force acting on the body is, so here you have applied a force on it. Okay, its weight, this is 2 kilograms, so 2g, okay, 20 Newton is going to act in the downward direction. This will be balanced by normal reaction. So normal reaction will be equal to 2g, or you can say 2 into 10, 20 Newton. 20 Newton. Okay. Now, in this direction, when you will try to when you will apply a force and you try to move this block to the right, then at this time some friction force will be there. Okay, this friction force will be there. Now if this applied force is greater than Fs maximum, okay, applied force is greater than this, then block will move. Then this block will move, and friction force will be actually kinetic friction, and its value will be given by mu k n or mu k mg. It will be. Okay. However, if this applied force F is less than or equal to Fs max, block will remain at rest. Block will remain at rest, and this force F, it will be static frictional force, and it will just balance the applied force. In that case, its value will be this. So first we have to find out Fs max. Fs max, you are aware that this will be mu s into n. So this will be equal to mu s and mg. So mu s is how much? This is 0.5. If you look at mass is 2 kilogram and g is 10. So this will be 5. So 5 to the 10 Newton. So from here you can observe that Fs max, ठीक है ना? Fs max, how much force is applied? This is 2.5 Newton. So what is the force? 2.5 Newton. So if you look at here, then this Fs max, that is 10 Newton, is greater than the applied force. Okay, so we are here. So we are here in the second case. F is less than Fs max. So what will be the friction force here? Friction force will be Fs. It will be just balancing this applied force. So this will be just 2.5 Newton. 2.5 Newton. So answer will be D. So your answer will be option D. So this was another question. This is another question. Now go to the next. Please note it down quickly. This one. Now you can have this type of question. Okay. Now how you are going to solve it? First, in this type of question, they are very simple questions. What you have to do, first apply the tension force. So on this block, if you consider there is a tension force T that is acting in this direction. This is T beta. Okay. So this is a single string. So a tension T is going to act in this direction. Another T is acting in this direction. Okay. This T will be these two T, that will be how much weight is acting in the downward direction. So this is 5G. So this 2T is actually 5G. So from here I can write upward force 2T, that is counterbalancing this its weight. ठीक है ना? Or what we have to find out? We have to find out acceleration. Okay. Suppose you want to find out acceleration of block A and B. Assume pulley is massless. Okay. In this case, we have to find out the acceleration. So that's okay. How will you find out? So for this purpose, I am saying, suppose this is moving in the direction with acceleration A. What will be the acceleration here? I'm assuming this as A1. I'm assuming this as A1. I will write this equation. So try to understand what will be the equation if it is moving in the, if this block is moving in this direction, this B is going to move in the downward direction. So this will be 5G. ठीक है 5G minus how much tension in the upward direction is, that is 2T, and this will be 5A1. 5A1. Try to understand whatever is its acceleration if it is moving 2 centimeter distance, because it is like this due to this type of loop, this block will move only 1 centimeter. So its acceleration will be half. So its acceleration is going to be half as compared to that. Okay? So this will be 5G, this will be. What will be the equation for this? What is the equation for this? Block A, this is tension T here. So this tension T is acting in this direction. And due to this tension, acceleration will be 2 of A. 2 of A. So what will be this? 5G. 5G minus, substitute this T here. So 2 2 is 4A. This will be 4A. And that will be equal to 5A1. 5A1. Now only one question is left. What is the correlation between this A1 and this A? What is the correlation between this A1 and A? I am telling you a very simple formula. Okay? Whenever this type of correlation you want to create, try to understand. Apply this. Sigma tension vector dot product with acceleration equal to 0. Apply this sigma for all the blocks. Whatever blocks are here, apply this sigma. So look here, first block A, tension is in this direction, acceleration A is in this direction. So T and A, they are in the same direction. So what I will write T A, this is a dot product. So this will be cos 0 because T and A, they are in the same direction. Plus second one here, this block is having acceleration in the downward direction and 2T tension in the upward direction. ठीक है ना? Tension on this block is 2T, that is acting in the upward direction. Acceleration is acting in the downward direction. So what will be? Tension that is acting is 2T. Acceleration is A1 and they are acting in the opposite direction. So this will be cos of 180 degree and that will be 0. So this will be TA. This will be cos A 180 minus 1. So this will be minus 2T. A1 is equal to 0. So T will cancel out and what you will find out A1? A1 is A by 2. So whatever I was just telling you, just observing it, you can find out from here. Any difficulty may be there related to this pulley problem in finding this relation between acceleration and tension or acceleration between different blocks, you can use this method. This equation you can always apply. ठीक है?
सर
Yes, beta, please.
ये बी बॉक्स के लिए, बी मास के लिए आपने जो इक्वेशन लिखा ना, वो राइट हैंड साइड में 5A1 कैसा है, एक बार बता दीजिए ना.
5 is this is a 5G, weight is acting downward. Is tension, how much tension is acting in the upward direction? Either you write here T2, T2 will be equal to 2T1. Try to understand why I'm writing. This T2 will be here and here it will be T2. So this T2 is equal to 2T, I'm directly writing. So this is 5G is acting downward. This T2 or 2T, that is acting in the upward direction. So 5G minus 2T, they are responsible for this acceleration A1. So mass of this is 5. So this will be 5A1. This will be 5A1.
Yes.
Is it okay? Beta? So this will be. So substitute this A1 here. ठीक है? Or you can write replace A2 by 2A1. A1, this is your choice. So I'm writing 5G. In place of A, I'm writing 2A1. So this will be minus 8A1 and 5A1. So what will be A1? A1 will be, this is 5 divided by 8 and 5, 13. And this will be G. This will be A1 beta. This is A1. So this block is moving with an acceleration 5 by 13G. 13G. If you substitute this A1 here, so A will be how much? A will be 2 times A1. So this will be 10 upon 13 into G. So this will be the value of acceleration A. It will be. Okay. So this will be the acceleration of both the blocks. In this way, I will discuss 2 or 3 more questions like this where you are going to use this type of relation. So this was the first one. Is it okay? Hello.
Yes, sir.
Next question, beta. Now, this one is there. A block A of weight 100 kilogram. So block A, mass of block A is 100 kilogram. कितना है बेटा? 100 kilogram. Next. Rest on a block B and is tied with a horizontal string to the wall at C. ठीक है ना? At C. Block B is of 200 kilogram. Lower block is of 200 kilogram. Upper block is of 100 kilogram. The coefficient of friction between A and B, ठीक है ना? Between A and B at this level, this is 0.25, and between B and C, B and surface, this, that is 1 by 3 here. 3. The horizontal force necessary to move the block B should be, कितना होना चाहिए? What should it be? What should be the minimum force F so that B will start moving? Now try to understand this block A. I'm drawing here for the block A. This is block A. This block is in contact with this B. So automatically a normal force is going to act on it. I call it as N1. N1, its weight is going to act in the downward direction. That will be MA into G. G. ठीक है? You are trying to pull this block in this direction. ठीक है ना? You are trying to move this block B by applying, you are trying to move this block B by applying the force. By applying the force. ठीक है? So automatically this block will move in this direction. So this A will have a relative motion in this direction. So this block is not going to move because it is attached with this. So a force is going on it in this direction. So in this direction, a static force is going to act. And if there is relative motion, it will be kinetic friction. It may be kinetic friction if there is relative motion between A and B, but here in this direction, and this F is going to counterbalance this tension. Tension is going to act here. If this block A, ठीक है ना, if this block A is experiencing a friction force in this direction, so automatically that friction force will try to move this block A in this direction. But who is countering it? Tension here. Tension in this string. So they will be exactly balanced here. What I want here, 2 equations I will get, that N1 is MA into G. This will be MAG. ठीक है? MAG. This will be. Second. Now look at this P. And second equation, you, even if you want, I don't need this one, but this will be F. F. That will be equal to T. T. And for the second block, this block is trying to move in this direction. So try to understand, if block is moving, so it is moving with respect to this A as well as lower surface. So on this, a friction force will act. And on the lower surface, it will act F here. This you can say F1. This will be F2 here. ठीक है? On the earth, if you look at, F2 is going to act over here. And on this block, in this direction, force F1, you can call it. So if you don't want, ठीक है ना, that this block should move, or you want to find out the minimum force so that it will move. For the minimum force, what is the rule? For block to move, for block B to move, what is the rule? Can anyone tell me? This force F should be greater than Fs maximum. Fs maximum. ठीक है? So here this will be Fs1 maximum. Here it should be F2s maximum. You are choosing maximum value of static friction forces which are possible here. So this F, if you want, F should be greater than this F1, yeah, F static force 1 max plus F S2 max. ठीक है? What will be F1? What is this Fs max? S1, because this force will be equal to this. So from here I can find out. Can anyone tell me what will be the value of this Fs1 max? Now I am writing here Fs1 max. बोलो बेटा. That will be mu S1, mu S1, N1. Or mu S1 is how much? 0.25 or 1 by 4. And S1 is MA into G. This will be. ठीक है? 1 by 4 MA into G. But question is, what happens on B? What is this F2 max? Can anyone tell me how will you find out F2 max? So F will be, I'm writing here half of the part. S1 max I have calculated 1 by 4. ठीक है? MA into G. This is okay. But what will be here in plus? Look at B. Look at B. Can you tell me how many forces are acting on it? One force is F that is acting here. That is okay. On this direction, in this direction, you can say, just 1 second. Can you tell me how much this will be? This is the friction force. Okay, this is the friction force. If you look at, if you are considering this connection, what will be this? I want to find out this as F. This block is in contact with the earth, so automatically a normal reaction is acting on it. Okay, I call it as N2. Try to understand. N2, its weight is acting downward, mg. But remember this, here A and B, they are in contact. If B is applying a normal reaction on A, then A is also going to apply a normal reaction on B, and that will be in the downward direction. So this will be N1. That will be N1. So what will be N2 here? N2 N2 reaction. What is N2? N2 is the reaction that Earth is applying on this block B, or this block B is applying on the Earth. That is normal reaction. N2 will not be just MBG. This is not MBG. This is MBG plus N1. And what is N1? N1 is MAG. So if you substitute here, this will be MB plus MA into G. This will be N2. Remember this, if you look into books, directly they are writing MA plus MB into G. That's okay. But how this is coming, you should be well aware. Because this normal reaction is also acting on this block in the downward direction. So this N2 will be equal to N1 plus MBG, its weight that is acting in the downward direction. So this will be N2. So what will be F2 max? Now can you write this F2 max? So this F2 max, Fs2 max static, this will be mu2, and this will be N2. What is mu2? Mu2 is 1 by 3. I'm writing here. This will be 1 by 3. 1 by 3 and N2 is this MA plus MB into G. MB into G. This will be. So here you can write this will be 1 by 4. What is the mass? 100. So this will be 100. ठीक है, G I will take common plus 1 by 3. And this will be 100 plus 200. So this will be 300. And G is common to both. So this is 25. ठीक है. This is 25 plus 100. So this will be 125. 125 here. And into G, so G will be 10. So this will be 1250 Newton. So this will be. So this will be F. So F should be minimum force. It will be 1250 when it is ready to start. So as you apply this much amount of force, okay, whose magnitude is 1250 Newton, then this block B, it will start moving in this direction. So this was a very good question, conceptually very good question. Okay, you are trying to move this block in this direction. So this block with respect to Earth is moving in this direction. So on the block, friction force will act in the opposite direction of the motion as well as this F1. Now, how will you find out F1 from block A? So you find out the normal reaction that is acting on A. From there, you can find out FS1 maximum. This will be. But for second block, two type of normal reactions are acting. One from the lower side, that is N2. One from the upper block, that is N1. And weight of this block, that is MBG, that is acting downward. So by balancing upward and downward force, you can find out N2. And then you can find out FS2 maximum. That will be mu2 N2. Substitute here, you will find out your answer. So this was also a very good question. So for today, I'm going to stop here. Okay, in the next class, I will further discuss questions. Then I will start discussing pseudo forces. Okay, after completing pseudo forces, numericals, where pseudo forces is coming into the picture, then I will start discussing work, energy, and power, which also includes the collision problem. Okay, I will also discuss collision problems there. ठीक है बेटा, please you can take a screenshot of all the slides. So this is the first one, beta. First slide. Second one. This is second. Second slide. Third one. Fourth. Fifth. Fifth. This is sixth. Six. Seven. Seven. Eight. Eight. Nine. 9. 10. 10 is this one. 10th. And last, this is 11. ठीक है, दिस इज 11. ओके बेटा, थैंक यू
थैंक यू
वेरी
सर।
मच. वेलकम
थैंक यू
बेटा.
सर.
थैंक यू बेटा. वेलकम बेटा. गुड नाइट.